Hello and welcome. We're live now, so sorry for a bit of a delay before we started. I'm going to talk today about package URLs, and thank you for joining. So the session is recorded and it will be available for replay afterwards. So let's start. Okay, so quick words about me. I'm the lead maintainer for ScanCode, VulnerableCode, and About Code projects. I'm also the creator of package URL, so it's a bit of a self-serving session in a way, but I think it has grown in importance beyond our original intention. I happen to be also a co-founder of SPDX. I contribute to CycloneDX. I co-founded ClearDefine and a few more things. So why are we here today? The things we build, software, they're getting more and more complex. We use ever more packages, most of them being free and open source software packages, FOSS. It's very common to have a system or application that contains 1,000, 5,000, 10,000 packages. And that's vastly more than we were using a few years ago. There's many reasons for this. First, there's more packages which are being created. That's one reason, but also we use more of them in containers. We have more complex application built from multiple technologies and language, which means that we end up using more of these. The cool thing about it that we can really now do component-based development of sorts, things that was all the rage in the 90s, but was more of a dream. Now there's open source package and libraries enabled it. We can take and glue together multiple libraries and tools pretty quickly and get really beautiful software built. The problem is that we have we have deep dependency trees. It's common when you use Node packages, JavaScript, to reuse a few direct dependencies and pull several hundreds, if not thousands. And you have dependencies not only on the application side, like JavaScript, Java, Python, but also system packages on Red Hat, SUSE, Debian, Alpine system, typically Linux system in most cases, but not only. And in many cases, you have a package, say for instance, the PsychoPG2 library in Python, which is a driver for talking to the Postgres database, of course requires the Postgres database to be useful. But one is a system package, Postgres, the other one is an application package, PsychoPG2, and you have these unstated dependencies that exist across ecosystems. And they're not always obvious because there's no way to express these in a way, shape, or form. The cool thing also about more packages and more components is that we have potentially more bugs, more licenses, and more security bug vulnerabilities. So that's where we are. There's also something which has been emerging in the last couple of years and it's been very much in the news, is software bill of materials, or SBOM, which is eventually an imperative for application security because of mandates, both in the US and Europe, emerging in Europe, already stated and established in the US. The central principle is fairly simple, is to say, I need to track an inventory of all the package and or components that are used to make a software application or system. And of course, you want to convey that. That's the whole point. You transfer this information to a third party that's receiving your software, so they're aware of what you use, and eventually, if there are known security issues, if there are license implications, and so on. In order to do any of this, you need to identify software packages. And that's the thing that you really need to do. In a way, origin determination and naming and identification of software package is probably even more important than license or security, because they are derived facts from the first origin and identification. So what if we could name a package just by looking at it, just by observing the package and says, oh, we know its name. And not give a name, really its true real name that's based on what it is, not some name that was given by someone else, or an identifier or a number that was given by someone. And make it so that it's both a name that's obvious and simple for human to read, and precise, accurate for machines, so it can be processed as a way. And so that can then be used to identify these packages, whether it's for composition analysis, vulnerability, dependency, license management, in a mostly universal way. And not replace any of the things we have, but rather have a standards that can sit side by side and sit on top. And you'd say, okay, that's the classic XKCD cartoon comic strip, which is to say, there's many standards, let's create one new standard, and there are more standards. There's a truth to that, but in this very case, it happens to be a good solution, because eventually this is working towards reducing the number of standards as opposed to expanding more standards. So, what are package URLs? So, as I said, so each package ecosystem has its own convention, and they have ways to name, locate, and provision software packages, and it's different in NuGet and NPM and PyPI. And the idea here was with this package URL to have a way to capture the convention in a way that's minimal. And so 2 examples here. I have a package called foobar in NPM. It's version 12.3.1. I have a PyPI Python package called Django 1.11.1. With this string, you have enough to go and figure out what is the exact corresponding source code and software that was used. And that sounds pretty simple, and that's what it wants to be. It's simple because it is simple, and it's been designed to be super easy and obvious. So it started in ScanCode and VulnerableCode. It's now adopted in many places. It's essentially a de facto standard used in many places. There are libraries that have been contributed by community. I don't code in all these languages, but that were contributed by many different actors that are pretty much covering all the languages. It happens to be recommended by the United States NTIA and CISA, the one that managed the National Vulnerability Database, as a relevant SBOM package identifier. In fact, I've been contacted a couple of times to make presentation at the US CISA on package URLs and discussion with the folks on the National Vulnerability Database, so we could exchange and they could understand what's behind package URL and how it could best use. So much so that the next iteration of the National Vulnerability Database in the US, versions 5.1, in the API version 5.1, going to go live probably sometime this summer, will have support for package URL, which is awesome. So, a bit of PURL history. It started, we had a simple problem for ScanCode Toolkit, where we are parsing many package manifest and dependency log files, and eventually with new tools also resolving dependencies. The problem was how to store very simply in the output of ScanCode the identifiers for each of these packages. And then at the same time, we're starting a new project called VulnerableCode, which is a database of known security bugs and vulnerabilities in open source packages. And we had the same problem, which is how can we connect the packages found by ScanCode to the vulnerabilities known in VulnerableCode. And there's something in vulnerabilities called CPEs, called Command Package Enumeration, which in contrast to package URL is a given name. Somebody decide arbitrarily someplace, somewhere, that zlib is called zlib, or zlib new zlib, or whatever. But it's not something I can just know by looking at the code or looking at the software. I need to know separately what is the CPE for zlib. If I don't know that, I cannot discover it. I cannot infer that. That's the whole difference with PURL, which is I just look at the code, I can read the manifest, and I have everything to figure out what is the PURL. And if on the other hand, I have a vulnerability database or a database of package metadata, which is keyed by PURL, then I can relate the two very naturally, very easily. And so that was the original use case. And we were parsing a mishmash of package manifests for many different ecosystems. We call them type in PURL speak, but everybody refers them to ecosystem. So I think it's better to call that ecosystem. And the interesting insight is within the confine of a package ecosystem, say Debian, or PyPI for Python, or RubyGems, or NPM, or Maven. Within this ecosystem, within the central repository that's available to the community, there's an ecosystem guarantee that each name is unique. And that's pretty strong, because having unique name means that you have unique identifiers. And this is obvious when you think of it, but it's pretty profound to say we have a file package version 5.3 in NPM, which is not the same as file version 5.3 in RubyGems. I don't know if this package exists, I just made them up, but the point is that there's surely a package called file on each side, and they're very different. They're not the same code. And now, if you just prefix the name and version with a short moniker for the ecosystem, you've removed the ambiguity, NPM versus gem, done. And the only addition on top of that has really been to add a PKG prefix, which is like HTTP in a web URL, to make it a valid URL, and ensure also it can be registered. I'm working on registration at IANA. I've already, between quotes, earmarked or cyber squatted the name, so they know that we're in progress of doing that. I've done a request for provisional registration, so that becomes a standard. And each of the types then being specific to an ecosystem ends up being defined in the spec, which is a part of the spec which says, oh, NPMs, that's how you find about them. That's the URL, that's the ecosystem. These are conventions that are used in this ecosystem. And for instance, we are using already in VulnerableCode an ecosystem called Apache for Apache package that provide a set of security advisories. So there are a few projects there that specifically report advisories, like Apache, I think Kafka is one, HTTPD, Tomcat, very, very popular and somehow also buggy projects because they churn out more code and they're more used, so there's more scrutiny. And they publish advisories, and we needed one way to reference this project. So we used Apache as a prefix, And no later than this afternoon, I've been in discussion with Apache folks at on their security mailing list, because they're looking forward to maybe use package URLs also as part of their ecosystem to precisely identify packages. And the rationale is ensuring that it's easy for someone that use Tomcat to say, hey, I'm using Tomcat 5.3, therefore this is the package URL, therefore this is how I'll be able to find information about this. Where can I download the source and binaries upstream at Apache? What are the known security issues, and so on and so on. So there were many other projects facing the similar problem at the same time. Or the Open Source Review Toolkit, folks at OpenShift, a project called Fabric8. There was a project at Google called Grapheas, and another one called libraries.io. All were facing similar issues. They were dealing with many open source packages and needed a way to basically identify them. At the same time, especially in the context of the Grapheas project, JFrog, that was working with Google on this project, had came with a similar approach. Instead of using a PKG generic URL, they were using npm as a scheme prefix in the URL, meaning that they would have had not one URL prefix, but like potentially 10, 20, 50, 100, which was potentially problematic because you cannot really easily register 100 package prefix or URL prefix at YANA. Several would have been already used. For instance, Go is already used, so you would have been able to use that for Go as Go package. And in fact, we don't use Go, we use Golang for Go packages. And in fact, the very first iteration of PURL, we're using the same approach. We're using npm colon and then the name or namespace and a version. We eventually discussed with many URL experts. When I mean URL experts, I mean really the folks that are handling the URL specs and the RFC definitions and working with the W3C for all of these. And we came down to use this prefix to make sure we could have a more streamlined and easy to spot set of URL. Eventually, we moved the spec from its early draft in some GitHub issue on ScanCode Toolkit to a separate org. And we invited as co-organizers several users that were really invested in the discussion. The key point here was to share control. And even though that was eventually something that started with ScanCode and I wanted to make sure that I was not the only control point there. And when it started, we also received several contributions of libraries specifically designed to parse in a given programming language. And from there on, it a bit snowballed. We had adoption that started quickly across many open source tools, but also vulnerability database and also SBOM standards. So we'll come to that in a sec. So now, fast forward today, who is using PURL? Of course, the tool that exists in About Code, so ScanCode, MatchCode, all the tools that deal with packages, we have VulnerableCode, are all using PURL. That's where it started. But most of the open source tools in the space of software composition analysis, container analysis, SBOM, are also using PURL. SBOM and VEX, vulnerability exploitability exchange standards, are also very much invested in PURL. It's a central identifier used by CycloneDX. It's also heavily used by SPDX. Most of the SBOM tools, for instance, the GitHub released a couple of days ago a way to generate an SBOM straight from a GitHub repo. an SBDX SBOM, it's all keyed by PURL. So they use PURL as external references, PURL as SPDX package identifiers all the way. It's used also by CSCF and OpenVex and SPDX, as I said. There's a good number also of proprietary software composition and InfoSec, AppSec tools that are using also the spec. And last but not least, vulnerability database. Google OSV is, as well as also the GitHub advisory database, but mostly the OSV schema. GitHub advisory database is based on the OSV schema, so they're using the same. Google OSV as a database also integrates actually code from VulnerableCode itself. We're very proud of that, which means we're probably doing something not too bad if there's some of our code that ends up reused in these tools of companies that have many more capabilities than us to develop a lot of code. Sonatype OSS index is also keyed by package URL, VulnerableCode, of course. There's the Cloud Security Alliance Global Security Database, which also use the OSV format and is keyed by PURL. And finally, the NVD, which in version 5.1 will have a PURL too. Beyond this, there's database of package metadata. I didn't put clear define because they're not exactly using PURL, but they're using something which maps essentially one-to-one with PURL. But there's a new PURLDB, which is a project of About Code that I want to establish as a database of package URLs and so package metadata, dependency information, file information that you can build and that we can provide as pre-populated as a set of reference, and eventually will be made public as a set of curated reference data. You have a more recent project called Ecosystems and Ocelot at Ozadol in Germany. All of these are using PURLs. And really, we have this SBOMs discussion, a lot of presentations saying, SBOMs are everywhere. The problem is there's many issues about what you can do with them. There's many different standards. There's not many tools that are able effectively to consume, or many teams. Recently, I was at FOSDEM, and there was a development room. So FOSDEM is a show in Belgium every year, end of January, big open source conference. And there was a conference track specialized on SBOM. There were about, at that time of the conference, about 50 people plus in that room, and somebody asked who was effectively able to read SBOMs as opposed to just write and create them. And out of the 50 plus people that were there, only 2 say, oh, yes, we're consuming SBOM. It was a bit surprising to me, but that's a fact. There's a lot of people that are creating things, very little that are reading them. There's a lot of potential issues about the depth, breadth, quality of this information which are conveyed in SBOM. Not all of them use PURL, unfortunately, and machine readable identifier, even though they can. But the thing is, irrespective of using SPDX or CycloneDX, if you have PURL on each side, this becomes a non-issue, because you'll be assured that the package called npm file 5.3 in this CycloneDX BOM is the same as the package called file 5.3 in this SPDX BOM. So the thing is that PURL are eventually emerging as a key identifying and unifying identifier across different specs. And because they're tiny and simple to use, they're very easy to embrace. I think it's really important that whichever standards of SBOM you embrace, you go with PURL. And I'm not the only one to say that. This is one of the VP at the Linux Foundation. I let you read the quote. That just stresses the importance of having these unique identifiers. They're more than just package URLs, but it's interesting to see that it's considered as the leading format for tracking packages. So really, PURL, and I'm super proud of that, is emerging as the essential glue. And I think it's glue to avoid locking. So you would say glue usually locks you in, but no, here it's a glue across tools to really avoid vendor locking, be it commercial vendor or open source vendor. Because it allows interop across different SBOMs, across tools. And if you have two tools that speak PURL, you'll be able to mix and match, replace with little friction. If you have a database of vulnerabilities that you subscribe commercially that speaks PURL, and you can then benchmark it against another database, maybe commercial or open source, and bearing the minor difference that may exist in the API for integration, the fact that they both speak PURL means that integration is going to be fairly straightforward in most cases. So please, I think you must demand adoption of PURL by your vendors and projects, open source projects and at large, because the benefits for you means less locking, be able to mix and match best-in-class tools, and eventually replace them if need be, and compare objectively the performance. If you do a scan, say, on a container, Docker image, Windows container, whatever, with tool A that spits PURL and tool B that spits PURL, you can compare objectively whether they were able to detect the same thing and report the same information. Another quote, which was, it's anonymous quote, because I didn't get permission, but it's a leader in the one of the SBOM specification, and basically the quote speaks volume too, basically saying from a coming from a professional like that, saying it has essentially transformed the landscape of application security and information security tooling. That's pretty telling, and it leads us to the conclusion. Basically, software composition analysis is not easy. It's hard, but it's even harder because there's no one tool that can just cater with all the different cases and all the different approaches and all different ways you build software and all the different types of software that exist, be it embedded device, IoTs, backend application, mobile application, all that. Each time you have a combination of language, tech stacks, which are very specific, and domain-specific technique for analysis. So it's hard. And the way to avoid making this a Babel mess where no tool can speak together without hard work is to use shared name. So license, package version, vulnerabilities, version control, like address for a Git repo, these kind of things. And the naming, so I'm referencing T.S. Eliot, which is a British poet, who was saying the naming of cat is a difficult matter. It's the name of one of his poems. And if you look a bit at all the different identifiers we have, I think for license expressions from SPDX are essentially there, and they've solved the issue mostly. With package URLs, we have a solution for package names. There's a new emerging mini-spec as part of PURL called verse for version range specifiers, which is a way to express a range of versions that may be vulnerable or that may be okay or not okay as a dependency. So it's for dependencies of vulnerable version ranges. I think with CVs and the many aliases we can assign to them, we have something okay for vulnerabilities. And finally, there's a spec, mini spec as part of SPDX for version control system URLs, which was borrowed from Python pip and is now in SPDX. If you look at all these domains, we end up having a pretty strong set of identifiers, which when used across different tools, SBOMs, database, mean that you can eventually mix and match these tools very efficiently. And that's pretty much it. So if you have questions now, I'll take the questions. And if you want to help, welcome help, be it in terms of code contributions, time, doc, or cache to any of these tools, so package URLs, but also the other tools I've talked about. Any question that would come up otherwise at this stage? Okay, so there's a question, what's the roadmap for PURL? There's a lot of pending PRs and issues that needs to be catered to. So there's a bit of a backlog there. A lot of people asking questions. I've been purposefully being very slow to jump on any core change on the spec and reasonably quick to accept change on new types, new support for new ecosystems. The key elements of the roadmap. So there's discussion right now to adopt a more formal governance organization. And I have mixed feeling about that. I think governance is great, but you don't want to have too much of it. It's a grassroots effort. It's been working very well without any friction and has had wide adoption without much of red tape and formal governance. But I can understand the willingness to have a bit more formality there. So the input comes from folks from GitHub and Microsoft that want a bit more governance, and we'll probably go with a bit more governance. But again, I want to thread lightly because governance has a bit of a bureaucratic ring to it, and we don't want to slow down innovation and decision making with a more complex bureaucratic process. So that's one. That's likely on the roadmap. The second topic is maybe finding a way to simplify the spec. So it's already very simple, but make it even simpler. We have today, let me go back to show an example of some PURL. You see here, that's a, let me create actually, yeah. So we have a notion of name and namespace. So for instance, in the context of a Maven PURL, the namespace would be what's called the group ID in Maven speak, and the name would be the artifact ID. There are a few other ecosystems that support namespace. NPM, it's called a scope. It's prefixed with an @ sign, is another example. We use also potentially namespace in other cases, but it's a bit artificial to have this namespace in many cases. For instance, for Go, Go packages, they're just basically a string. It may live in some website, maybe in a Git repo in many cases, but not always. And it's very hard to determine what is namespace from what is the name in this case. And so the idea in terms of evolution would be to say, no, doesn't matter. Namespace, name, you do whatever you want, and we specify it for each package type, of course. But the fact that there's one or more segments separated by a slash between name and namespace doesn't really matter. And that wouldn't change anything in terms of the spec itself, the output, the package URL string. It would just change how it's parsed and how you split basically that in name and namespace. And even that could stay the same, just that the name and namespace would be always considered as a single thing and not as two separate entities. And the last and third thing is the version ranges, which is this ability to have a specification of a set of version, or whether it's a version dependency, so saying, hey, I depend on Django version 1.11 or higher, but under version 2, this kind of thing. Or all the versions between version 12 and 14 of foobar in NPM are vulnerable to CV123. Version 15 actually fixes this CV. The same, slightly different usage, but same concept. You need to express a version range. You could enumerate all the versions, of course, but if you have projects with hundreds of versions, that's not super practical. And several projects have many different version lines for the more popular ones, so it's really a useful concept to be able to state and express these version ranges. So it would be the three things. To recap, governance. Second, merging name and namespace. And three, adopting a way to report version ranges to support both functional dependency ranges and vulnerable ranges for packages. Okay, any other questions otherwise? Okay. Well, thank you very much for attending. And I wish you a wonderful day, and thank you for listening to this presentation. Goodbye.